we are going to discuss about the strength of acids and bases. Now, first let's see what you understand by a monobasic acid, dibasic acid or a polybasic acid. So, what do you mean by a monobasic acid? Monobasic acid means acid which has only one ionizable proton. So, here we have only one ionizable proton, that is H+. For example, HCl. This is a monobasic acid because HCl will ionize or dissociate to give H++ Cl-. We have only one ionizable proton. Now, dibasic acids. Dibasic acid means there will be two ionizable protons. For example, H2SO4. We have two ionizable H+ ions, so it's a dibasic acid. Now we have polybasic acid. Polybasic acid means two and more than two ionizable H+ ion, they are polybasic acid. For example, H3PO4. It's a polybasic acid because there are three ionizable H+ ion. Now, I am going to take H2SO4 and write its ionization equations. So, H2SO4. We know that H2SO4 will dissociate to give, first step we get one H+. When one H+ is removed from H2SO4, we get HSO4-. Now, in the second step, we have HSO4-, which ionize to give, from HSO4-, one more H+ is removed. Now, when one H+ is removed from HSO4-, we get SO4-2-. So, we say that this H2SO4, since it ionizes in two steps or there are two ionizable proton in H2SO4, we can call it a dibasic acid. And these are the two ionization steps. This is the first ionization step and this is the second ionization step for sulfuric acid. Now, I am going to write the dissociation constant expression for these two steps. So, for the first step, this is the first step. I am going to write the expression for dissociation constant Ka. Now here, since this is the first step, I am going to write Ka1. So what will be the expression for Ka1? Ka1 will be concentration of H+ into concentration of HSO4- divided by concentration of H2SO4. Now, for the second step also, I can write an expression for the dissociation constant. And for the second step, I can write Ka2. What is the expression? The expression is concentration of H+ into concentration of SO4-2- divided by concentration of HSO4-. Now, we will have a value for Ka1 and Ka2, and also we can say the overall dissociation constant will be overall dissociation constant Ka will be the product of first and second dissociation constant values. So, Ka1 is called the first dissociation constant value, Ka2 is called the second dissociation constant value, and the overall dissociation constant Ka value for sulfuric acid will be the product of Ka1 and Ka2. Now, this Ka value, that value of Ka, it's a very important value, and this Ka value gives us the measure of strength of an acid. So, we can predict from Ka value whether the acid is strong or weak. Now, how can we predict? The rule is like this: higher the value of Ka, stronger is the acid. So, higher the value of Ka, stronger is the acid. So this is a very important point that is to be noted. So when different Ka values of different acids are given, and if you are asked to arrange in increasing order of their acid strength, we have to check. The one with higher Ka value will be the strongest acid. Now again we have a question here. Now for sulfuric acid we have Ka1 and Ka2 value. Also for H3PO4 we will have H3PO4 is phosphoric acid, and H3PO4 you can have 3 ionizable proton because there are 3 hydrogen. So we will have Ka1, Ka2 and Ka3 values. Okay, now the question is, why is Ka1 value greater than Ka2, greater than Ka3? Very important question. That is Ka1 greater than Ka2 greater than Ka3. Why? The reason is, when I say Ka1 value, here that H plus ion in sulfuric acid is removed from the neutral H2SO4 molecule. Whereas when I write for Ka2 expression, that H plus ion is removed from a negatively charged species. That is, you can see H plus is removed from HSO4 minus. So it's more difficult to remove a positively charged proton from a negative ion due to electrostatic forces. And greater the charge of the negative ion, more difficult it is to remove the H plus ion. Okay, so always we have Ka1 value greater than Ka2, greater than Ka3, etc. Now, next let's see the factors affecting acid strength. So next is the factors affecting acid strength. Now the two main factors that affect the strength of an acid is the strength and polarity of the HA bond, that is strength and polarity of HA. HA is the general representation of an acid. Okay, HA bond. So these two things decide the strength of an acid, whether it is a strong acid or a weak acid. The strength of the bond and polarity of the bond. Now, when we say the strength of the bond, about the strength of the bond, HA bond. Now, when the strength of the bond is less, that is the HA bond strength is less, in that case it's very easy to break the bond, which means that hydrogen can be easily removed as H plus ion and stronger will be the acid. So we can say when strength of HA bond decreases, acidity increases, or it becomes a stronger acid. Okay, now let's consider the polarity. Polarity means the electronegativity difference between hydrogen and A. Now, when the electronegativity difference is very large, in that case, what happens? The cleavage of bond becomes easy and it becomes a stronger acid. So, next you can write when electronegativity difference is high, then bond cleavage is easy and stronger is the acid, or the acidity increases. Okay, so these 2 points are very important when we discuss about the factors. One is the strength of HA bond and the other is the electronegativity difference. Okay, now again the next point that you have noticed, when we compare elements in the same group of the periodic table. So when we take the elements of same group, group 1, group 2, like that. When you take the elements, here we have to consider the HA bond strength. We have to consider, or HA bond strength is the more important factor in determining the acidity. Okay, so when we consider elements of same group, HA bond strength is considered or is important. Because we know that down the group, when we go, the size of the atom increases. So bond length decreases, bond cleavage is very easy. So acidic character or acid becomes very strong down the group. Okay, so I am going to write that down the group. What happens down the group? Size of atom increases. Then HA bond strength decreases and acidity or acid character increases. Now, if we take group 17 elements, group 17, you have hydrogen fluoride, HF, chlorine, HCl, HBr, HI, hydrofluoric acid, hydrochloric acid, hydrobromic acid and hydroiodic acid. These are the 4 acids, and you know here down the group, what happens? Size increases. So iodine has the biggest size. So HI bond strength decreases, acidity increases. So which has maximum acidity among the hydrogen halides? Among hydrogen halides, the maximum acidity is for HI and least acidic is HF. So if you are asked to arrange in increasing order of acidity, HF less than HCl less than HBr less than HI. So HI is the most, hydroiodic acid is the most acidic and HF is weakly acidic, weak acid, and HI is a strong acid. Okay, so this is the order, because down the group size increases, acid strength increases. Now next, when we consider the elements in a period, elements in a period. Now when you consider elements in a period, here we have to consider the HA bond polarity instead of bond strength. So here bond polarity is important. Bond polarity is important because we know that when the electronegativity difference increases, strength of the acid increases. For example, if you take the molecules, that is methane, ammonia, water and HF. If you take, you can see this central atom in methane is carbon, here nitrogen, then here oxygen, and here we have fluorine. Now when you take these molecules, you can see the maximum electronegativity difference is for HF, H2O comes after that, NH3 after that, CH4 has the lowest electronegativity difference, means the electronegativity difference between carbon and hydrogen is very less, but hydrogen and fluorine is very high. So in this case you can see that the electronegativity difference increases in this order. So when electronegativity difference increases, we know that acidity increases. So when you're asked to arrange in increasing order, we can say methane less than, ammonia less than, water less than HF. So this is the increasing order of acid strength for these molecules. So when the electronegativity difference is very high, acidic character increases. Same way, when the size increases, acidic character increases. Okay, so here also we have HF as the strongest acid and methane has the weakest acidic character. Now we have a question here, that is, arrange in increasing order of acidity given the Ka value. So 3 acids are given, oxalic acid, carbonic acid and citric acid, and their Ka values are given. And I told you, Ka value, higher the Ka value, stronger is the acid. So when you check the Ka values, which value is higher? Here it is 5.9 into 10 raised to minus 2, which means 0.05. Now here we have 10 raised to minus 7, here we have 10 raised to minus 4. So which we have to arrange in increasing order. So which has the lowest Ka value here? Lowest is for carbonic acid. So we can write carbonic acid. It's increasing order. Increasing order we will write from small to big with less than sign. So carbonic acid less than, next comes our citric acid, less than oxalic acid. Now one more question we have, that is which is more acidic, H2O or H2S? Which is more acidic? Now here the central atom in H2O is oxygen and H2S is sulfur. And we know oxygen and sulfur, they come in the same group. That is group number 16. We have oxygen, sulfur, selenium, tellurium, like that. So oxygen and sulfur we have in group 16. So when we consider the elements in a group, we are taking the strength or size as an important factor. So we know down the group size increases. So sulfur has more size, so that HS bond strength decreases, acidity increases. So which is more acidic here? H2S is more acidic than H2O because sulfur has more size than oxygen. So HS bond strength decreases, acidity increases, which means it's very easy to lose that hydrogen as H plus ion. Okay, so H2S is more acidic than H2O. So with this we complete the strength of an acid, the different factors that decide the strength of an acid. Thank you.